Good afternoon. My name is Jessica Rye, and we could not be more thrilled that you have joined us for the United Launch Alliance Next Generation Launch System News Conference. I would like to introduce ULA's President and CEO, Tori Bruno. He will join us shortly, but first I'd like to share this great video about the cool work we do at ULA.
Well, good afternoon, and thank you all for coming. I love that video. That was 14 launches last year, and that's just a year's work. There'll be another 13 or so this year. But we're here to talk about the new rocket, and I could not be more excited to do that with you. This is an absolutely thrilling time to be involved in space. I mean, here we are at United Launch Alliance. We are about to go launch our 100th rocket later this summer. In a few minutes, I'm going to reveal to you our next generation launch system. But you know, it's really about much more than that. It is about realizing the true commercial potential of space, where we will tap its resources, we will make this world a smaller and much more intimate place, and we will see our human presence permanently, practically, and ubiquitously beyond our planet. And this new rocket is going to play a big role in making all of that happen. It's going to take the best parts of Delta and Atlas and combine them with new and advanced technology to provide a rocket that is not just reliable and certain as Atlas has been, but also much more powerful, higher performance, greater flexibility, and significantly more affordable. Now, I came to ULA to transform our company and make space much more accessible than it has ever been before. And this new rocket is a key part of that vision. And in a few moments, I'm going to reveal to you what the name is. I know you're dying to find out, but I'm just going to torture you for a few minutes because I have to tell you about the rocket and the technology that's in it. I'm a rocket scientist. I'm sorry, I just have to do that. And so if you could go, thank you, to the first slide. We're going to do this in 4 steps. The first step is this much more powerful booster. It will sit atop a pair of advanced technology Blue Origin BE-4 rocket engines. These will burn clean and inherently reusable liquid oxygen and methane fuel. They are also going to bring into America, in an American-built rocket, the advanced oxygen-rich staged combustion engine cycle that has yet to be produced in the United States. Much higher efficiency, much higher performance. They will replace the venerable RD-180s, which generate today 930,000 pounds of thrust. This twin pair of BE-4s will kick that up to well over 1.1 million pounds of thrust, a significant improvement in performance. They will sit underneath a stretched set of tanks that will contain significantly more propellant so that we can take advantage of that increased power to provide more impulse as we go to space. And we will have up to 6, we used to fly 5, now 6 solid rocket motor boosters. This will provide up to 20% more power. This will be a significant improvement in performance, and these will be the largest SRBs that are monolithic and currently in production at that time. This booster is a significant improvement in performance, and it truly is a conqueror of Earth's gravity well and will lift our upper stage and our larger payloads up out of that gravity well so that they can do their job. We will first fly this in 2019. Atop it will rest initially our current Centaur upper stage, the highest performance upper stage ever developed. But that's not going to be enough. We're going to take a giant leap forward in our upper stage in step 2. Go to the next slide, please. We are going to move to an advanced cryogenic upper stage, burning liquid oxygen and hydrogen. It will start with these very large, high-capacity balloon tanks We call them balloon tanks because they are so thin, so lightweight, that on Earth they cannot even support their own mass. They would collapse without propellant or pressure in them to hold their shape. They are truly designed to fly in space. And underneath them will be 1 to 4 rocket engines. And in the coming years, we will down select between our existing Aerojet Rocketdyne RL-10s, or perhaps the Blue Origin 3 upper stage engine, or the new technology in the X-Core engine. This will have a significant increase in the total impulse on orbit, but that isn't actually the most exciting part about this upper stage. The exciting part is what's on the far right-hand side, the integrated fluid vehicle system. This is the ultimate in reuse. The thing that limits the performance of upper stage systems in launch vehicles is time and space. For the lower performance conventional systems like other people fly, within a short period of time, that very cold space environment ends their life, freezes their propellants, locks them up. Even for us, with our advanced high performance upper stage in the Centaur, we're limited by time. Eventually our propellants boil off and we're out of usable propellant. This system changes all of that. So we will use an advanced internal combustion engine that will take those waste propellants and recycle them to repressurize our tanks, to generate electrical power, and to provide control thrust and attitude thrust for this upper stage system. This completely changes everything. I mean, not only do we collapse from 3 subsystems to 1 with simplified systems and lower costs, but what it really does is a tremendous extension of our ability to operate on orbit. We're going to go from hours to weeks with this system, and that will open up a whole universe of possibilities. We can take multiple satellites into orbit. We can put them in different planes. When we get done with that, we can fly back to the space station for operations. We can do all sorts of things. And I'm going to come back to that in a couple of steps later and talk about really the true potential of what that will do. We're building this engine together with Roush, the race car company, and so this upper stage really is a Formula race car of space. So I'm very excited about this. Go to the next slide, please. Now I'd like to talk about smart, modular, advanced reuse technology. So this is a distinctly separate approach from what other people are doing. So this allows us to avoid adding complex, expensive, heavy, and performance-killing subsystems to a rocket in order to bring entire stages back that then experience complicated and expensive logistics to recover them. Instead, we took a systems engineering approach to what on the rocket is actually valuable. And for example, when we look at the first stage booster, which this is, we find out right away that fully 65% of the cost of the value of a first stage is in one thing. It's in the rocket engines. And yet they are a small fraction of the weight. And so in this approach, when the booster is done and we're finished with the rocket engines, we will cut them off. We will return them to the Earth using an advanced inflatable hypersonic heat shield. And then with a very low simplified logistics footprint, we will recover them in midair, bring them home to the factory, quickly recertify them, and then plop them right under the next booster in the line. This will take up to 90% of the propulsion cost out of the booster. And this is just the beginning. I'm actually not going to show you what other candidates and what other plans we have for this, because I think it would be fun for people in the space enthusiast community to apply this thought process and have a chance to use their imagination and see what they think we might release later on in terms of where else we will use this approach and this technology. Go to the next slide, please. Now this is the real game changer. This is our 4th step, distributed launch. We'll be flying this out in about 2024. And this is enabled by that advanced upper stage I talked about. Today, the concept for launching objects, for satellites, for missions into space is highly constrained. It's trapped into the notion that the spacecraft has to be completely self-contained physically. Everything that's there has to be there on the pad. If it's a satellite, it must fit inside the nose fairing. If it's a capsule, it has to fit inside that capsule envelope. And once it goes up, there is no opportunity really to meaningfully, physically interact with it. That upper stage shatters that limitation and opens up this possibility of distributed lift. And so we could take our first launch, big fuel tanks, supplies, food, water if it's a manned mission. And the next flight will bring up the spacecraft or the astronauts in their capsule. And with this advanced upper stage, which can fly around for weeks, it's up there waiting, we can put these pieces together. And now outside the deep part of Earth's gravity well, with that much impulse and propellant, we can do anything. We can go out and tap the resources that are in space. We can asteroid mine. We can build the infrastructure required for a real and permanent human presence. Fuel depots, water depots, commercial human habitats. This is truly a game changer, and I could not be more excited about what this will do for the future of space, all enabled by that advanced, high-performance, ultra-long duration upper stage. Go to the next slide, please. So when we sort of bring it all together, what are we looking at? We're looking at 350+% more lift. We're looking at an order of magnitude more duration in operations that are virtually nearly unlimited. For all practical purposes, unlimited starts and restarts of this system. We can do anything that you might imagine a permanent presence, a true commercial exploitation of space would require. All of that infrastructure that's truly required to see the potential of space can now be put together. Go to the next slide. Now my PA people, they hate this, the PR people hate this, but I could not help but give you one teaser for something I'm not going to talk about today. But in addition to the new rocket, we are going to revolutionize the way that people purchase launch services. Buying a ride to space is going to be as simple as buying a car. And later this year, we're all going to get back together, and I'm going to tell you about something we call fast buy and ready launch that is going to make that revolution possible. So stay tuned. I'm not going to talk about it today. Sorry. All right, so, you know, when we started this, I thought, wow, I am so excited about what this architecture can do. You know, it is America's next ride to space. I should let America have a hand in naming it. So we thought, well, let's go out and let people vote. And I thought, well, this will be fun, you know, we'll get a few thousand people involved, and they'll get online, and we'll get votes. I was astonished at what happened. The passion and enthusiasm around this literally blew me away. We have well over 1 million votes for the name of this rocket. And so I'm going to reveal it to you now. We have hats here. These were the top 3 candidates. So is it Galaxy 1? No, it is not. This is a collector's item now. Laura, you get it. How about Zeus? No, not Zeus. You can have that one. Oh, we'll get that for you. It's Vulcan. Behold, the powerful Vulcan rocket. All right, we're going to do Q&A, but first, I thought you might want to hear from our employees because they are the most passionate about this. And so we've got a really cool video of our people talking about it. Can we run that, please?
We're on track and building the foundation for what is going to be the highest performing rocket in the world.
It's something that in our whole industry doesn't happen all that often, you know, maybe once a decade, if that.
There's not many times that you create a new rocket or develop a new rocket and do it in 4 years.
NGLS is America's next ride to space.
The NGLS is a game changer.
So NGLS is ULA's next generation launch system.
You know, we're going to take the best of both worlds from Atlas and Delta, integrate those into an NGLS rocket that's going to knock the socks off of anything that we got to date.
So it's really kind of mixing our 2 fleets today into one rocket that hopefully we'll leverage all the lessons learned and all the knowledge that we have, and then add some innovative ideas to make this system stand on the shoulders of what we've done before.
So we're going to be able to offer with NGLS capability to go to LEO all the way to interplanetary missions with a single launch system. which allows us to reduce infrastructure and really streamline our entire process.
We have a unique opportunity right now to implement and pursue this new design, this new launch system that will lower our costs for our customer.
Where we can generate new ideas, new concepts, take advantage of new technologies for manufacturing, for materials.
How can we make this better? How can we make it more efficient and cost effective and time effective? So we're looking at things like autoclave and additive manufacturing, some new welding techniques that we might be able to implement, 3D printing opportunities. NGLS really is a game changer about how we do business.
The next generation launch system is going to be powered by an American-made first stage engine that runs on liquid natural gas. And our second stage is going to be using our heritage Centaur from the Atlas V launch system. We're going to offer it in our existing base of 4-meter and 5-meter fairings with the ability to tailor our customers' performance requirements by adding solids.
It's a new engine. It's not something that we've used on either rocket before. We're excited about that. The next generation launch vehicle is a game changer. It eliminates our reliance on the RD-180. It combines the technologies that we have from Atlas V and Delta IV, and even incorporates some new innovative ideas.
There's no doubt in my mind that we have some of the most talented, some of the most brilliant people in the world working at our company. We have the world's best collection of rocket scientists to make this thing happen.
NGLS is definitely America's next ride to space. We're so excited to get to provide that and to provide the performance, the mission success, and the affordability that our customers need.
There are no bounds to who we are serving with NGLS. It really is a global advantage that we're providing for humankind as a whole. We're already America's ride to space. We're going to continue to be America's ride to space. NGLS is going to be the top choice for Americans and for any global company that wants the performance and cost benefit that we're going to provide.
All right. Thank you. All right. Hold that thought. I want to bring a couple of folks up to help me answer questions. So first, I'd like to invite up Dr. George Sowers. He is our chief mad scientist. He led the team that came up with this architecture. And also Mark Peller. He is our Vulcan rocket program manager. He is the man that will bring this to the pad in 2019. Okay, and with that.
Please wait for the mic, state your name and affiliation first. Warren, we'll go to you first. I saw your hand up.
I've got you over here. Thanks. Warren First with Space News. So how much is this whole thing going to cost and who's going to pay for it?
So this rocket capability, which starts down around the Atlas 401 and can modularly grow to more capability than the Delta Heavy. So this is a tremendously flexible platform. It starts at under $100 million a lift.
No. To develop the Vulcan rocket, engine, new vehicle, whole thing.
Sure.
We're talking, this is a couple of $1 billion, right?
So we're not talking about how much it costs.
Okay. How about who's paying for it?
We are paying for it. Ourselves, ULA, and our strategic partners are funding this out of our profits. However, I will not turn down help if anyone, including the government, would like to invest.
So by strategic partners, you mean your parent companies?
No, I don't.
So
I mean
not
Blue Origin.
Not Boeing and not
No.
Lockheed Martin?
So Boeing and Lockheed Martin own us 50-50. We're a separate company. We send them our profits when we earn them. So they are investing in the sense that they are allowing us to retain profits in order to invest in this rocket.
Okay.
All right, Amy, I saw your hand up.
Hi, Amy Butler with Aviation Week. Quick question on the ACES, and then I have a larger question on the bigger strategic marketplace. The ACES, you didn't provide any dates unless I missed it because we were going quite quickly.
23. So we'll first fly that advanced upper stage in 2023.
And when do you expect to begin testing it?
We've actually begun testing components already.
Okay. And then outside of that, I'm curious what you as a company are doing to prepare for a potential life after the ELC contract. How are you going to do your pricing with the government? And how do you view a level playing field for the intermediate competitions that are to come?
Sure. So when I come back to talk to you about Fast Buy and Ready Launch, I'm going to share the details of all of that with you. But essentially what we are doing is moving to a standard product offering. We're going to make our launch services available at a known fixed price in advance, upon which, if you have additional requirements, you can buy fixed and known modules on top of that. We'll do it in a single contract, sort of the old-fashioned way, where we no longer have a separate production contract and a separate launch contract like we do today. We'll bundle them all together. But I have a question for you. So you read the acronym and you called it ACES. Is that a good name, or should we have another voting thing for a name for the upper stage? What do you think?
But there is an ejection seat called ACES, so you might want to be aware of that.
So that doesn't sound right. So it sounds like you're voting for another naming contest. All right, you heard it.
Okay. Bill Young with African American Voice. Actually, I have two questions for you, and the first one's probably the more complicated and difficult one. I don't know that, though. With your projected starting price being 39% higher than some of the competition, is your plan that because you can do larger payloads, that people will be combining payloads to launch with you, or that they're going to start creating larger things? What's your strategy behind that?
Yes.
Okay. That was a little too easy. Didn't expect it to go that quickly. So the second question, and it gets to the amount of money that you're spending to launch this, so forth. Are you stretching out your base platform in regard to where you're doing research and development and pulling things together? Or, for instance, I understand there's going to be a space campus in Colorado Springs. Are you going to be a part of that? What's the strategy on how you're going to
You're asking about physical footprint?
Yes.
No. So we have our Engineering and Program Management Center in Centennial, Colorado, just up the road. Our factory's in Decatur. It's going to stay in Decatur, as well as our other factory in Harlingen, Texas. We'll continue to fly out of the two coasts we do now, Cape Canaveral and Vandenberg, but we will have fewer pads. We're going to move with new innovative designs on our pads from 5 that we have today to 2, 1 on each coast. And that'll handle the same or even higher volume of the lift that we are doing today by having these advanced, really innovative approaches to launch.
Hi, Aaron Meadow with Defense News. You mentioned that the ACES, or whatever it'll be called eventually, would be 2023.
Amy says we can't call it ACES.
I always listen to Amy, so it's good. You also said the distributed launch kind of technique would be tried out in 2024, I believe is what you said. You said in the past that 2022, 2023 is when you imagined the Vulcan would be certified for
national security.
For national security.
Yeah.
So is there a timetable for when you expect those extra capabilities to be certified for that, or is that something you envision having to come down the road?
Well, I expect that we'll first use those capabilities on commercial flights, which is separate from what the government does for certification. Certification is dependent on the rocket and its configuration. I expect there will be some Delta certification activity associated with the kinds of payloads we will use in distributed launch. Now, somebody's going to ask me a technical question so my rocket scientists can answer them. Who's got one?
We're going right back behind Aaron. Yep, and then we'll come back up to Amy for the technical question.
Ian Fitzenbaum of AIAC. I wanted to ask about launch cadence and launch rate. What kind of capability are you designing it for, and what kind of launch rate do you expect the market to demand you serve in the time frame that you're going to be operating this?
Sure. So the launch rate we're designing it for is actually higher than what we fly today, because we expect as we grow into the future, when we come through this flat part in national security space and we have added commercial and civil launches, and then the United States enters into the recapitalization of the on-orbit assets, the demand is going to increase significantly.
Any numbers?
Oh, how about 20?
Per year?
Yeah,
Per
why
month?
not? No, per year. Well, let's not get crazy here. Okay.
All right, we're going to give it back to Andrea and then up to Amy.
Hi, Tori Andrea Shalal with
Hey,
Reuters.
Andrea.
Hi. I wanted to ask you about sort of the government, the assured access to space
Mhm.
policy. Now, since you've decided to not fly Delta, that still leaves the Delta Force in this interim period.
Yes.
But, will this mean that eventually you're sort of accepting that there will be United Launch Alliance and SpaceX in this market? And how do you see the future sort of going? And just to get back to Amy's question too about the phasing out of the ELC contract, has the government already given you kind of a plan for when that will end? And can you share a little bit of that with us?
Sure. So I heard you ask two questions. First, who do I anticipate being the providers involved in the lift market? And then, has the government given me a plan around the ELC contract framework? So first, the players that I see over the next decade are the same players we have today. I fully expect SpaceX to be certified this year, like the Air Force says they will be, and so they will enter the national security lift market. And then we will continue to do civil and commercial with ourselves, SpaceX, Ariane, Proton, and Orbital. Now, in terms of has the government given me a plan? No, they haven't. But I am planning that the ELC contract will probably run its course associated with the launches in the block buy, and I don't expect to see that construct going forward, which is unfortunate because of the tremendous flexibility that's provided to the United States government. Remember why they decided to break the launch contract out separately from the contract that manufactures the rockets. There's a tremendous urgency to replace the satellites that are on orbit now. Most of them are far beyond their design life. And the satellites that are coming down the pipe to replace them are not always predictable in exactly when they will show up on the launch pad. That means that whatever satellite shows up, it needs to go into space right then. And having the launch contract broken out separately has allowed them tremendous flexibility to do that. Last year alone, in a manifest of 14 flights, we shuffled that manifest 11 times, all without any impact to the government, without any additional costs or the renegotiation of contracts, none of that. So that was a tremendous advantage for them during that high volume lift point. But going forward, that volume's going to drop off, and I believe that they will probably do without that construct.
What time period do you expect it to end?
The current contract's period of performance is over in 19, and so that would be the end of that contract. I don't expect any of the current competitive contracts that everyone is chasing now. Remember, competition in national security space started last year. I don't expect any of those will have that construct. It'll be the old-fashioned way. One contract, production and launch together for whatever the quantity of lifts is going to be.
I'm sorry, just to clarify. So the current contract runs through 2019. The current contract runs through 2019, and then but you're competing for other contracts between then.
Yes.
So how will that be factored in when you have a competitor?
So remember that the ELC, the lift contract, some people have called it a subsidy. It's not a subsidy. It is simply a separate contract for lift. And whenever we launch or sell a separate lift for anyone, including the Air Force, we pay a thing called tonic. We reimburse the government $17 million every time we lift somebody else's rocket. So I expect that arrangement will continue all the way through until that's completed.
All right, I'd like to take a question from Ask ULA.
We have our first Twitter question, and it's Vulcan new upper stage first launch is expected in 2023. Is that the same year for the entire system?
No, we're going to do this in 4 steps. So we're a conventional business, which means, as I explained, we earn profit and then we take the money out of the profit in order to fund this development activity. So we're doing it more or less serially. First the booster, then the upper stage, then the reuse concept, and so on, as I explained it.
All right, so we're going to go back in the room. People who want to give some people who haven't had a chance. We'll go here and then up to Frank.
Okay, Scott Johnson with Spaceflight Insider.
Hi, Scott.
2 quick questions. Which pads are you going to continue to use both at Cape Canaveral and Vandenberg?
Good, a question I can kick to Mark Pellin.
And then maybe a slightly more technical, can somebody provide a little bit more explanation on the engine recovery scheme?
Sure. George, that one's yours. So Mark, why don't you go first?
So we are still working to develop the details of our launch pad of the future. Our plan is, as Tori mentioned, to launch from Cape Canaveral Air Force Station and Vandenberg Air Force Base. And what we're looking at is leveraging our existing assets in place at those facilities, but it's not going to be just your a reuse of your current Atlas V or Delta IV pads. We plan some very extensive modifications for those to provide that flexible facility that we need so that this product line can address the real diversity of customer requirements we see coming down the road. And as Tori mentioned, we'll have some more information here in a couple of months about that pad of the future and specifically what facilities we'll use at those 2 sites.
Okay, George.
Okay, the reuse concept is fairly straightforward. What we're going to do is once the booster has done its job and gotten the upper stage to that sort of intermediate trajectory point, we're going to separate the upper stage, then we're going to sever the engine off the bottom of the booster. It's above the atmosphere at that point in time, but it's in a hypersonic state, well beyond the speed of sound. We'll deploy an inflatable hypersonic decelerator. And this is technology that we're currently working with NASA on. It's part of one of their game-changing technology programs. And then once the engine is safely through the hypersonic part of the environment, then we'll deploy a parafoil, slows down even further, and then we're going to snatch it out of the air with a helicopter and land it on a depending on the trajectory, landed either back on land or on a barge of some kind or a ship. But the beauty of that scheme is that the environment of the engine on its reentry and recovery is perfectly controlled. It does not see any of the hot plasma gases from the hypersonics, and it certainly does not see any salt water.
Frank Boring with Aviation Week, also for Dr. Sowers. Could you walk us through the upper stage? I'm a little bit lost. What do you do with the internal combustion engine? How much propellant do you carry in those large tanks? And are you talking about using these, I think they're all 3 cryogenic engines that you're looking at, for in-space propulsion to way on out there?
Yeah, so the ACES is a concept that we've actually been working on for quite a few years, and there's papers out there for your reference that you can go take a look at. But it is a LOX hydrogen upper stage. So it's a high energy upper stage. It has the same steel construction. Tori referred to it as a balloon tank, but it's a pressure stabilized tank, thin-walled stainless steel. So it has a very, very high mass fraction, very efficient design. The integrated vehicle fluids is, like Tori said, is really the key to expanding the capabilities of the stage. And what it does is it takes 3 fluids that we currently have to supply. The main propellants, we have helium for pressurization and hydrazine for attitude control. We're eliminating the helium and the hydrazine, and we're using boil-off gas, otherwise which would be wasted. Gas, hydrogen, and oxygen that otherwise would boil off because they're cold in an environment that would boil them off. So we're taking those waste gases and running it through the internal combustion engine. That internal combustion engine is attached to a compressor, which then allows us to pressurize. We've also developed a hydrogen and oxygen thruster, which we use for attitude control. And then it also runs an alternator generator like your car does for electrical power. But it allows us to have unlimited engine restarts, allows us to refuel the stage and reuse it like we would do in a distributed lift kind of concept, and it eliminates some of the issues that make long duration almost impossible. So this stage is designed for very long duration, on the order of weeks, even months.
And you would use electric propulsion with that?
No, it's cryogenic propulsion. So it's hydrogen oxygen engines, like our current Centaur upper stage.
Yeah, Chuck Lauer, Space Access Japan. A big picture question. It used to be that if you were talking about a commercial launch, you had to go switch to the Lockheed Launch Services hat, and if you were a government launch, it was ULA. You have a lot of commercial terms in your briefing. Is ULA literally the one-stop shop for all customers now? So that's the big picture question. And then the detail question, there was an announcement a few months ago about a collaboration on commercial space capabilities with JSC. ULA got an award on that. Is this program part of CCSC?
I'll take the first one. I'll let you talk to the second one. Okay. So I'll see you later in the year to talk about fast buy and ready launch. Okay, George, take it away.
Short answer is yes, it is. A lot of the technologies that we're incorporating are part of the Space Act agreement that we have with a number of different NASA centers. Yes.
All right, Warren, and then we're going to go to Ask ULA and back to Amy.
Hi, Warren Firster again. Tori, I'm going to push a little harder on the question that Chuck asked because I believe it's in the consent decree that set up ULA that you can't sell launches commercially. And Lockheed sells the Atlas, they buy the Atlas from you, and then they sell that on the commercial market. The Boeing does not commercialize the Delta IV, and I'm just wondering how that arrangement's going to work going forward if you're using the Vulcan vehicle.
So actually, it's not in the consent decree. It is in our joint venture operating agreement. So it's something internal to the company and its two owners. And once again, I'm not going to give it away. You got to wait for Fast Buy. I'll be back in June, I believe.
Okay, one other quick question if I could. So you say this combines Atlas and Delta hardware and technology. So give me some examples. I know, for example, with the Atlas, you've got, initially you're going to have the Centaur upper stage. Can you give me some more examples of the Atlas and the Delta technology? For example, the tanks. Is it going to be a Delta IV main tank?
So it'll be modified from. So remember I said these will be stretched tanks that'll carry more propellant to take full advantage of the increased power of the engine, the increased thrust. So we'll take, for example, with the methane on the first stage, we'll take a Delta tank and we'll stretch it. So it'll be derived from. We're also in the process of developing common avionics elements right now for Delta and for Atlas. That subsystem will come straight across into the new rocket. And there'll be other examples like that. Does that help?
So what about the fairing?
We're going to bring our existing fairings across, although we're making a modification to our 4-meter fairing to give it additional volume, and we're doing that now in advance of all of
But you're going to
this.
use both vehicle fairings, both Atlas V?
4-meter and the 5-meter fairing.
But the same, those are different fairings today, no?
They are different fairings, and we'll bring them across onto this
okay,
vehicle.
So both can be used on both?
Yes.
Okay.
We're going to Ask ULA.
Tori, you mentioned that NGLS will be produced in Decatur. When will production start?
Production's going to start in just a couple of years based on long lead times. Go ahead, talk to that.
We'll start building qual hardware in late 2016, early 2017 to support structural qualification of tanks and so forth, things of that nature. Our partners at Blue Origin are already started with production of development hardware and are actually in tests with development hardware for key elements of the engine at their facility.
Up here to Amy.
Thank you. Amy Butler, Aviation Week. I just want to ask you about certification. It's been a thorny path for SpaceX, according to SpaceX. I wonder if you could talk to us about your plan to apply for certification. When do you want to do that? Have you already engaged the Air Force and what process you wish to take to do that? And then also, how will you certify your reused first stage engine?
So yes, we have already started. So you begin the certification process by writing a letter to the Air Force and telling them, I'm going to have a new rocket, and here's my approach for certification, and how we will navigate the guide that they produce. So we have already done all of that. I think the fundamental difference in our approach to certification is we intend to continue our policy of transparency with the government. So we have invited them now, literally when we first began this path, to engage with us, to attend design reviews, to participate and have that visibility as we move through the development process, so that instead of ending that, having finished all our work, so we think, without really letting the government participate in, and backing up the semi-truck and dropping all the qual test data on them and all the drawings and all of the processes and plans, we're going to bring them along all the way. And of course, remember, as a certified provider already, part of that activity is to make sure that your processes are certified so that the government can assure themselves not only do you have a good design, and not only did the qualification hardware work the way it was supposed to and pass those tests, but that you have the ability to make the next unit and the next unit and the next unit all the same. That's what the process piece is. They already have tremendous insight to our processes as an existing certified provider.
So when did you send that letter requesting?
When did we send the letter?
It was early February of this year.
And was it accepted? Did the Air Force say yes? And
Yes, but it's not something that the Air Force necessarily approves. It's a declaration of intent, and then we work together on a detailed plan.
And when do you expect that plan to be?
Go ahead, Mark.
The CRADA.
So we are working with them. Basically, the statement of intent kicked off that process to develop the detailed certification plan, and that's an extensive effort involving both ULA and the Air Force to develop the details of that. And we are actively working that right now. We expect in the August timeframe we should be at a point where we're ready to sign off on that, for both parties to sign off.
And then reusability on the engine?
Same story. Yeah. Go ahead, guys.
What we submitted, this statement of intent for certification, was for step 1 of the program. So the new updated booster. Step 2 or 3 with ACES or smart reuse would be a separate certification plan, a Delta plan, if you will, that we would work with them at the appropriate time.
Okay. In addition, we're fully engaged with the commission that's been established by the Air Force under Retired General Welsh, so we can take full advantage of any lessons learned that came out of the SpaceX experience.
Just have a follow-up on the engine question. So it sounds more and more like you are not moving forward with the Aerojet Rocketdyne engine. Is that, I mean, have you made that decision yet?
No,
or are you,
absolutely not.
And can you just walk us through?
Sure.
What I'm having difficulty understanding is how you can proceed with this certification process without knowing what's going to be providing the propulsion. And I mean, I'm sure there's a way that you can explain it to me. I just am not quite grasping it, though.
So first, let me walk you through the approach, and then I'll talk about the statement of intent relative to those two. So we have selected our primary path. It is Blue Origin. They have very exciting technology. They are 2 to 3 years into their development when we intersected with them, and they brought to the table, along with us, funding that would allow us to start immediately and not wait for the government to get moving. That's our plan A. Now, rocketry's hard, and the engine is the hardest part, and they do not often go as planned, and so it is prudent for us to have a backup plan. I mean, I'll be honest with you, replacing the RD-180 and being on this path is a huge investment in a major decision for a lift company like ours. So we've got a backup. And our backup is Aerojet Rocketdyne. They have come to the table with an innovative design. It is a conventional propellant, kerosene, like we have now on the Atlas. They are 1 to 2 years behind in our judgment where our primary path is. We're going to take both of them forward until at least the end of 2016 before we make a decision, and then we will have to, for affordability reasons, retire one option and continue with the other. The statement of intent on certification addressed both paths. It talked to the one engine and it talked to the other engine. And so you will be looking for a down select from us sometime in the next 18 to 20, 24 months, or 12 to 18 months.
Hi, Courtney Alvin with Inside the Air Force. This may be kind of a technically ignorant question, but with the way that you're kind of iteratively developing these 4 kind of components, could potentially the booster, I guess, power the Atlas V, before the complete rocket is
Well, Courtney, you could sort of think of step 1 as doing that, because above the booster, in that first increment, everything that you see on Atlas today will still be on Atlas. So we're essentially pulling the booster out from under Atlas, sliding a new booster underneath.
So in terms of the, Congress's mandate that the RD-180 be phased out by 2019, or with whatever nuances there are attached to that, potentially this could address that issue.
This is exactly why the booster is going first.
Okay.
Had we not felt the urgency to move to an American engine, we would actually have started with the advanced upper stage.
Following up on that, I guess maybe this is for George. Does that mean you essentially have a seamless transition for the commercial crew customers of your current lift capacity, that there would be no significant re-engineering or requalification for either Boeing or anybody else that chose to use your booster for commercial crew?
That's exactly right. Because the front end of the rocket, the top half of it is the same as today's Atlas, at least in step one. All of the interfaces for the CST-100 at the launch pad and on the rocket are identical to what they are for Atlas.
And so you could also then support Sierra Nevada on a commercial.
Sure, any of the crew providers that are currently integrated to Atlas would have a seamless transition to this vehicle.
At a lower cost.
At a lower cost, yes.
Right.
Aaron Mehta with Defense News again. Can you just maybe go into the distributed launch concept of operations a little bit and kind of touch on it lightly, but explain kind of how this is going to work, kind of the timing on it, just what the benefits are, and if there's a way you could touch on maybe the military application for that, that'd be great.
Sure. Go ahead, George.
Okay, so in its simplest form, the distributed launch is the ability to launch very heavy payloads without a really big rocket. So the first launch would be a full tank of propellant that would loiter on orbit. Second launch would be your payload. When the first launch upper stage has completed its first orbital burn and depleted its propellants, it rendezvous with the tanker that's already there, it refuels, and away it goes. The leverage you get with two launches, you get far more than 2x the performance capability. So that has to do with the way the energetics work out. With it's kind of like a sophisticated form of staging, but you get a lot of leverage and you get the ability to do missions that you couldn't otherwise do. And then you combine that. That's the simplest form with two launches. You can add more launches. You can add refuelings at other points. It's easiest way to think about it is the airplane analogy. A fighter jet, to do a long duration mission, has to be refueled in many cases many times. Dramatically, it extends its range. That's all we're doing with upper stages.
Can you give us maybe an example of a mission where that would apply best?
A great mission would be, cargo resupply to a space station in a Lagrange point.
Okay, you were talking about human habitat situations. What are you going to do for energy up there? Is there any talk about utilizing the modular nuclear power plants that Taylor Wilson has come up with and some other people? What would that look like? What are the concerns and what are the benefits?
So the answer is yes. George, why don't you expand on that?
So, we're really the transportation company. We've been working with folks like Bob Bigelow for many, many years, and they're developing the architecture for the habitats. What we're providing with some of these concepts like distributed lift is the ability to supply those stations and habitats with logistics, crew transportation or cargo resupply.
Thank you. Can you give us an update on when you expect to fly your last Delta IV, and as well as your Delta IV Heavy?
Sure. So we will stop producing Delta IV single stick in 2018. We expect to fly the last one in 19. I have told, and personally committed to the NRO and the Air Force, that we will keep the Delta IV Heavy available until they are able to gracefully transition to the Vulcan rocket. I expect that to be out in the 23, 24 time frame, but it'll really be up to them.
And can you respond to Secretary Young's claim that if you were to retire Atlas and dual manifest everything on Delta IV Heavy, he claimed that that could actually reduce the price of Delta IV Heavy to the point where it would be competitive against Falcon 9. Can you respond to that claim?
Yeah, so I don't recall the specific comment, but I'll talk about the topic. How's that?
You talked to a lot of reporters about it.
Okay, all right. So certainly if we took the entire manifest and we moved it to one of the two rockets, the unit cost of that rocket goes down by volume production. Today we fly twice as often on Atlas as we do on Delta. So if we took everything that was on Atlas, we put it on Delta, Delta would cost less than Delta costs today. But Delta is inherently more expensive than Atlas. It truly is not competitive in the commercial marketplace. On average, it's 30% more. Its design is not as producible, its components are more expensive. So it is not possible to make Delta ever less expensive than Atlas, for example, on a one-to-one basis. And of course, a Delta Heavy is 3 Delta rockets bolted together, so it's 3 times that problem.
Do you have a price differential between Delta IV Heavy and your heaviest Vulcan?
So a Delta IV Heavy at today's launch rates costs about $400 million, give or take, depending on the mission and its complexity. I fully expect NGLS to be half that.
Less.
Less than half that. George said less than half.
For a Heavy.
Okay.
All right, we'll go to the back for an Ask ULA question.
We have a question from Twitter. Can you explain more how Roush Racing will be developed in the upper stage engine?
Yeah, George, why don't you take that one?
Yeah, so we talked earlier about the integrated vehicle fluid system. The central component of that system is an internal combustion engine that's currently being developed by Roush. It's not a big engine. I mean, don't think about, it's not the size of a race car engine. It's more like the size of a lawnmower engine and would easily fit on this table. But it does embody the same high-performance technology that Roush uses in its race car engines.
Any more questions in there? More?
Just a quick question about the solid. Tori, you mentioned the solid would be the largest monolithic solid in use. Is it the same solid that you're using today on Atlas V?
Not likely. So we have 2 solid providers today. We're going to consolidate to a single for this application, and we are going to expect more performance from that rocket engine.
So rocket motor. Competition between the 2 providers and down select? Okay.
Andrea and then Courtney. Andrea and
oh, sorry. What's the current state of play in terms of how many RD-180 engines do you have? Are you expecting more deliveries? And how are the Russians responding to the discussions, both the political discussions, but then also your industrial considerations? And how do you wind down that relationship? When, you know.
Sure. So let me kind of go in reverse order, and you catch me if I forget a part of the question. So in terms of our supply, how the Russians are reacting to the political environment, on the industrial side, there's really no reaction. The supply continues to be solid. We have engines under contract being produced now. There is no interruption in their frequency of delivery. Our current contract that was placed just prior to hostilities in the Crimea was for 29. That contract is proceeding. I expect no difficulties receiving any of those orders. That will be insufficient to take us all the way to the time frame when we have the new American engine available, so we will need to purchase more engines in order to bridge that gap, and then that will be likely the final purchase.
Can you just, how many do you have? You had said at some point when this discussion first began in earnest that you had a 2-year backup supply.
Yes, we maintain a 2-year backlog.
So how many of those 29 engines have been delivered, and how many more will you get?
Do you remember off the top of your head how many of the 29 we have on hand?
So 5 of those 29 have been delivered. 18 of those 29 have completed production and have been hot fired in Russia and will be delivered shortly. The balance of the 11 are in various stages of production and test.
And let me expand on the 2 years. I know you know this, Andrea, but for others. So the reason we stay about 2 years ahead is to mitigate the risk of supply. If something were to happen to that supply under a national state of emergency, we could transition entirely to Delta within about that time frame. And so that protects our nation in its ability to launch critical national security assets.
This may have been touched on earlier in the certification questions, but just to clarify, would the Air Force have to certify the booster to power the this new booster to power the Atlas V, or is the certification just apply to like a full new launch vehicle?
So the certification we're working on now is for step 1, which is that new booster I described, with everything else above that being the same.
So that does require that Air Force.
That requires,
Okay.
yes,
Okay.
absolutely.
Pat and then George. I saw your hand up.
Hi, Pat Host with Defense Daily.
Hi, Pat.
Tori, I saw, all right, I want to make sure I have this correct. So after the engine is dropped by the booster, it's going to re-enter into atmosphere with the shield, right?
Yes.
Okay, I think, could you explain how, I saw you guys had a picture of a Chinook type helicopter. Now, isn't the engine going to be going like 1,000,000 miles an hour? How are you actually going to catch that
Sure.
with a helicopter?
So 2 things happen before it gets to the helicopter. Not quite 1,000,000 miles an hour. But
Fast.
Fast,
Fast.
you know, 10 to 15,000 miles an hour. So the inflatable aerodynamic shield will significantly decelerate the engine on its way in, especially as it passes through the thickest part of the atmosphere. At that point, we then are going to deploy a parachute, you know, a steerable foil parachute, and that will fly it. They're guided. It actually flies it to a rendezvous point where the helicopter will kind of gently come in as it's floating along and scoop it up. Did I leave anything interesting out of that, George?
No, if you saw the Orion reentry, it's almost exactly like that. Orion had its own heat shield, which was part of the capsule. The engines won't have that, so we'll have to deploy one of those things and inflate it. But then it'll have a heat shield, and it goes really fast. It slows down by the heat shield, but then the chute's deployed to slow it down even further to where a helicopter can snag it with a hook.
What are you going to use to scoop it?
So the helicopter has a big boom with a hook on it that's also steerable, and we come up next to the parafoil and we grab on.
George Torres, Smithsonian Air and Space.
Hey,
Just a
George.
question on 2019. The vehicle you'll have then, with a new booster and 6 solids, potentially, what capability would that give? It sounds like you'd be getting close to a Delta IV Heavy.
So right there, we are significantly more capable than Atlas. We're still short of the Delta Heavy. We have to go all the way to the ACES upper stage, at which point we have, depending on the orbit, as much as 30% more capability than a Delta Heavy.
Okay, so in 2019, is that 50,000, 45,000?
Pick your favorite orbit and give us a number, George. 25 metric tons
20% more than current Atlas, which is 25 tons.
To 25,000 GTO.
Yeah. I'd like to go back to the Rouse racing bit. Internal combustion engines and rockets normally don't show up in the same sentence. Did you approach them or did they approach you? And from a technical standpoint, you've got low pressure gaseous hydrogen and oxygen in the tanks. Are they using sort of like a supercharger where they're drawing their own feed in to be able to make this engine work in a vacuum environment?
Yeah, so we've worked with Roush probably close to 10 years now, and I think we first made contact with them through X-Core. They were working with X-Core on piston pumps for the X-Core engine. But from an IC standpoint, yeah, you do have to, you know, it works off hydrogen and oxygen, so it's, you know, a little bit of an untraditional fuel for an IC engine. But it does operate off the low pressure side, and the IC is what provides the energy, you know, the combustion of that to pump it up to higher pressures.
So they have their own they're gathering the gas under their own engine power and basically sucking it into the manifolds to get it to run.
Yeah, I think it would be better probably offline. We could show you some pictures and show you all the details.
Then in the racing model, there's typically a sponsorship element involved. So is ULA a sponsor of Roush, or is Roush a sponsor of ULA for the next launch?
That's a good question. I think Pennzoil should be in there somewhere.
Lauren, you had your hand up. Are you good? Okay. Amy and Andrea and then Aaron, and then we got to wrap up. So quick questions.
Thank you. Do you guys have a chart you could give us, or could you walk us through the different configurations that you plan to offer? As you know, now we have the 401, the 551, and all that stuff that we could actually see graphically.
We have that for you.
Okay, great. And then I'm curious. I'm not sure I quite understand what's going to happen with the ELC contract. I realize it is going to have to go away. Everyone gets that. What I don't understand is, does that get you through the current block buy, all 36 cores? And is there any discussion of it not getting through the current block buy?
There has been no discussion. And let me clarify. So when we talk ELC, we have to talk 78. Right, because remember, the ELC is the contract to launch rockets, and it launches the 36 cores, which is 28 missions, plus 50 missions from prior production.
Right, okay. Okay, and then for all of this new development work that you're doing, you are not able to tap into any ELC assets or any block buy assets, is that correct?
No,
okay.
This is separate investment activity.
Okay, and I've got to try again. Our editors always want us to say the X billion-dollar program, you know, the $400 billion JSF, for example. Is there a round number we could attribute to this program?
For this?
Yes.
For this development activity?
Development, procurement, however you want to scope it for us.
So I'm not going to give you a number, but I will help you a little bit with your editor in terms of giving you a feel for what it has typically cost in the past to do this kind of work. So typically people will use a rule of thumb at $1 billion or more to develop a new rocket engine, and $1 billion or more to put a rocket on top of it.
Okay. If we can be quick, we'll go to Andrea and Aaron, and then we'll have to wrap up.
Hi, this is another one of those trying again questions.
You guys are persistent.
Well, when United Launch Alliance was created, it was done because there weren't enough launches out there for either Lockheed or Boeing to survive sort of on their own, and the government wanted to have assured access. You know, the market's still not wildly exciting, right? You know, you're talking about 20 launches a year or something. You know, is this market, this future market, going to be big enough to support United Launch Alliance with its two owners that all want profit and money and shareholders that want returns, and another competitor like SpaceX?
Yes, only when taken as a complete lift market. So as you're pointing out, the national security market is going to dip down 18, 19, 20, 21. It's going to dip to a lower level than it is now before it climbs back up. So we have to look at the entire market, civil, commercial, and national security space, in order to support more than one provider.
And you feel confident that this is all worth it?
Oh yes, absolutely.
And your shareholders, your owners, are supportive?
Our shareholders, our owners' most critical concern is not actually about that market or that market projection, but about our continued availability of the RD-180 long enough for us to introduce this new engine. That's their concern. Because remember, Congress has said, we need you to move off the RD-180. And I have said, I absolutely agree. We do need to move off. It takes 5 to 7 years to develop a new rocket engine, and we are in a, sort of in a race to bring our new rocket engine on board before Congress's mandated end of use of RD-180 in national security space comes to pass. That's our owner's primary worry bead about this entire business plan.
Well, I mean, since you mentioned the chronology, I mean, there's quite a bit of discussion about, not being able to make it by 2019.
Yeah, so 2019 gives us essentially no margin. And that's why we don't think that's a very good plan. We would like to have a little bit more flexibility in order to get to the new engine. Things often happen in advanced technology development. And so to have a plan that is without margin is risking having a gap or a period of time when there is only one national security space provider, and that one provider is potentially unable to satisfy the full spectrum of national security missions. So not a good place for our country to be in.
All right, we need to move up to Aaron, and then we'll wrap.
Thanks. You mentioned the boosters and that you want to start a competition for that. Who's going to be involved in that? What's the timetable? What parameters are you looking for in terms of performance, cost, et cetera?
So we are going to use all of the United States domestic producers of large solid rocket motor boosters. That would be Orbital ATK and Aerojet Rocketdyne. Was there a second part I forgot?
The timetable and what you're looking for.
So we are potentially going to go out with an RFP this year. And then we, depending on what we learn, we will proceed as expeditiously as possible. Okay, thank you all for coming.